Above Sierre, in the canton of Valais, the river Dala flows from the Gemmi Massif to discharge into the Rhone near Loesch. At this point, the river has cut a deep gorge which was, until recently, an unpassable natural obstacle. On the left bank of the gorge stands the town of Loesch, an important regional center, where medieval houses contrast with the nearby telecommunication installations. On the right bank stands the village of Varonne, renowned for its vineyards and wines. A short while ago, Loesch and Varonne joined forces in order to ask the authorities for a bridge to link their communities. Thus, the children of Varonne would be able to go to school in Loesch. In 1987, after having studied many possible solutions, the Public Works Department of the Canton of Valais proposed a cable-stayed concrete bridge. A group of contractors and engineers then proposed a frame bridge as an alternative solution, given the topographic and geological conditions of the site. In 1988, the client, persuaded by technical, aesthetic and economic arguments, opted to proceed with the construction of the frame bridge. The structure has a total length of 210 meters and the leg foundations are 170 meters apart. The composite construction called for 950 tons of high-strength weathering steel. The steel structure, consisting of box-section deck beams and legs, supports a 13-meter-wide concrete deck slab. Construction work began in 1988 with the delicate operation of placing two working platforms on the steep sides of the gorge. These platforms were needed for the construction of the leg foundations. Due to problems of access, experienced climbers carried out this work. Meanwhile, in the contractors' workshops, the elements of the steel structure were being fabricated. The rectangular box section members were built up from cut plates. Preheating was needed before welding the thick plates of high tensile steel. The internal welds were made manually, and an automatic process was used for the longitudinal external welds. Fabrication was completed with the attachment of shear connectors used to ensure composite action between the beams and slab. On site, work continued with construction of the leg foundations and abutments. Abutment construction posed minor problems compared to the task of anchoring blocks of concrete to the sides of the gorge in order to form the leg foundations. In April 1988, the foundations were ready to receive the first leg segments. The erection of the steel structure was certainly the most spectacular phase of construction. It involved the combined rotation of the legs and launching of the deck beams into their final position. Initially, the legs were assembled in the vertical position. A length of deck beams was then assembled and one end attached to the legs with the other resting on a sliding support. The deck beams were then pulled out into the gorge, causing the legs to rotate into their final position. The deck beams were then launched over the legs. The same operation was then repeated on the other side of the gorge. In April 1989, erection began with the assembling of the legs. They were supported on temporary bearings which would allow the eventual rotation of the legs into their final position. Leg segments were lifted into place by mobile crane and then welded together while positioned vertically. During this operation, the legs were anchored to the sides of the gorge, and temporary bracing between each pair of legs restrained them transversely. Finally, a temporary frame was added to support the deck beams. To further complicate these operations, all work had to be carried out beneath overhead high-tension power lines. The deck beam segments, as well as the rest of the steelwork, were transported to site by road. These segments, weighing up to 42 tons, were assembled in an area behind the abutment. Joint edges were beveled in order to facilitate a double-sided butt weld. All site joints were made with manual metal arc welds and then subjected to ultrasonic testing. Once the required lengths of deck beam had been assembled, they were attached to the legs. In July 1989, the structure was ready for the first rotate and launch operation, a process which lasted 8 hours. The front ends of the deck beams were attached to the legs with temporary articulated joints. The trailing ends slid on beams, supported laterally and vertically by skates. At the start of the rotate and launch operation, a jack fixed to the center of the abutment pulled the deck beams by means of a cable attached to their trailing ends, and thus rotated the legs towards the gorge. Beyond the point at which its self-weight would cause the steelwork to fall into the gorge, two 330-ton capacity restraining jacks carried the load. The jacks then gradually paid out two cables attached to the temporary frame fixed to the legs. Mobile and fixed anchor blocks were used to allow the jacks to pay out many meters of cable, always carrying the load. While lowering the structure, the cables were locked at the fixed anchor block on the piston. During retraction of the piston, the cables were locked at the mobile anchor block. Here, the rotate and launch operation is seen at 1,000 times actual speed. Once the legs were in their final positions, the temporary bearings at their feet were replaced by the final fixed supports. The restraining cables remained in place until the steelwork erection was completed. The launching of the deck beams then began. As the launch progressed, new segments were welded to the trailing ends of the deck beams until the midspan was reached. The deck beams were launched by an electrically driven screw jack with a capacity of 100 tons. The beams slid over rollers on the abutment and legs. The launch on the lowish side was nearing completion when work began on the other side. The erection of the steelwork on the right bank was a repeat of the operation on the left bank, except for the use of the assembled deck beams as a platform for the erection of the legs. In November 1989, the second launch was completed and the final structural system could be implemented. Continuity was provided for the deck beams at mid-span and the legs were then welded to the deck beams. The restraining cables could then be disconnected. The temporary frame and bracing would be removed from the legs once concreting was completed. Concreting of the deck slab began in spring 1990. Deck slab construction was carried out with the aid of traveling formwork supported by the deck beams. The slab was poured in 16 stages, each 13 meters long, at a rate of 1 per week. Concrete was delivered to site by road and then distributed to the deck by conveyor belt. In total, 800 cubic meters of concrete were placed. Concrete quality was assured in accordance with the most recent codes of practice. Particular attention was paid to frost resistance. Numerous tests were made in the lab and on site before the fresh concrete was placed. Voids were formed around the shear connectors so that pre-stressing could be applied only to the deck slab without stressing the steelwork. 9 longitudinal pre-stressing cables were installed over the full length of the deck in order to limit cracking of the concrete. After pre-stressing, the voids around the shear connectors were filled. The deck was completed with the addition of waterproofing, surfacing, safety barriers, and parapets. With the construction work completed, a series of tests were carried out before opening. Static tests involved the placing of loaded trucks in predefined positions. The measured deflections were then compared to those already calculated. For the dynamic tests, a new technique was used. Vibrations were induced with the aid of rockets fixed to the bridge deck. Sensors placed on the deck enabled the measurement of amplitude and frequency of vibrations in 3 directions. All the data needed to determine the dynamic characteristics of the bridge were recorded in the control center. Lateral vibration was induced by repositioning the rockets. On December 14, 1990, after having passed all tests, the bridge was opened to traffic. In the presence of political and religious authorities, and in an atmosphere of village celebration, the two communities met on the bridge that they had long awaited.
Mit der Eröffnung der Straße Fahrenleuk geht ein lang ersehnter Wunsch des sehenden Leuk in Erfüllung.
Seit langer Zeit war die Verbindung Fahrenleuk für die Region Leuk ein Straßenbauprojekt erster Priorität.
Segne diese Brücke.
Sie gewähre sicheren Übergang und erleichtere unsere Wege.